with 5-4, we're going to graph rational functions, and we are going to look at different types of rational functions today. So far you guys have only seen one type, and that's when we did the inverse variation, but there's actually many different types of rational functions. We're going to start with the parent function today. So by the end of today, you'll be able to graph rational functions and transform them by changing parameters. And that just means we're going to be dealing with different equations, okay? All right, now, some of this stuff is going to come back to you, okay? But we're going to do a quick review of some of our graphing and some of our techniques when we have transformations, okay? So the first thing says the absolute value of A. I'm going to zoom it in because I know that stuff is kind of small. And you have a vertical stretch or compression, okay, and you have a reflection. So that is related to that value on top, the A value. Same thing here. If A is negative, it's a reflection. So if there was a negative out there, that would tell you there's a reflection across the x-axis. The other one that you could have, so this is the vertical stretch. We really are not going to be dealing with this, but if you did have a factor in front of the x like the 1 over b, then there would be a horizontal stretch or compression, just like in the past. So you can just add that 1 over b to the front. That would be the factor. Remember how it's always in front of the x? But like I said, we're not going to be doing a lot with that part. The main parts we're going to focus on today are the translations that are horizontal and vertical. So you have the h value here. That's a horizontal translation. Okay, and then it's left when the h value is negative, right when the h value is positive. So we're going to talk about the h values. Just remember this minus here also means the opposite. So it's the opposite of what you see. And that is standard with what we've been doing with these types of functions. Okay? And then your k value, that's going to be the vertical translation, so your up or down. And these are going to be related to asymptotes. So the asymptotes are important in rational functions. Do you guys remember what the name of the graph is? Close. Hyperbola, yeah. So the graph is called a hyperbola. Okay, and a hyperbola has a basic form, which is this one, but there are many different types of these. This is just for the parent function. So a parent function in the rational family is just 1 over x. 1 over your value of x. And we're going to point out where the asymptotes are, and I use a highlighter because it's very hard to see on here. So when you're doing your homework, you can also use a highlighter or a colored pen. And this is a vertical line. Every vertical line is x equals, so this is x equals 0. And then you have another one. So these two make a plus sign. Y equals 0. And that is the horizontal and vertical asymptote, and we're going to be exploring those a lot today. Now the points, remember, you can generate points by just plugging in certain values. So they do have the points there for you, but let's just think about what are some of my x values, right? So I'm going to give you those x's to plug in, and then we're going to find the y's. Okay, so if I plug in 1 for x, what's 1 divided by 1? Yep. So then my point is 1, 1. If I plug in 2, 1 over 2 is just 1/2, right? So I can leave it like that. The next one I'm going to plug in is 1/2. What's 1 divided by 1/2? Yeah, it's 2, right? You multiply by the reciprocal. Really, remember how we checked with the direct variation, how they multiplied to the top number? 1 times 1 is 1. 2 times 1/2 is 1. 1/2 times 2 is 1. Okay? And then that's where these points are. This is at 1, 1. Okay? This one's at 2, 1/2. And this one's at 1/2, 2. And that creates one of the branches, but with a hyperbola, there's at least 2 branches. So the ones we were doing before, there were only 2. Today we might get crazy and add a third one. Okay, so there are some that have 3 parts to it. All right, so to do the negative branch, we can just do -1, -2, -1/2. So again, -1 times -1 is going to make 1, right? Or 1 divided by -2 is -1/2. And that's what's going to generate these points. -1, -1, -2 here. Did you guys notice that I didn't do those in order, like from the lowest number to the highest number? That's because I like to start with numbers that are whole numbers, and then I have to go back and fill in different parts so that my branch looks good. So we'll be exploring that today as well, and I'll show you how to make your table on your graphing calculator work for you so that you can have a really good looking graph, okay? All right, now there's something special about this line here, okay? At x equals 0, there's a vertical asymptote, and that is because at this point, the graph is undefined. This is special to the vertical asymptotes, that you'll have undefined parts. Okay, and then the reason why is if you were to plug in 0 for x, what would you get? Yeah, well, not 0, but you'd have 1 divided by 0. What happens when we try to do anything divided by 0? Yeah, it's undefined. You get, if you try to do the calculation, you get an error. Okay, so that's why this is our asymptote here. So there is a connection there, and we're going to look at that today as well. All right, so for, taking more time with this one. Okay, so for the next thing, we're going to talk about the asymptotes and the domain and the range. Okay, so the first one is a vertical asymptote, and that is at x equals h. I'm going to draw a happy cloud here. That's for my Bob Ross fans, happy cloud. Okay, and then with the vertical asymptote, the x equals h value, notice that that's in the denominator, right? When we were doing this, we would always say the denominator couldn't equal 0. Remember when we were talking about the domain in chapter 6, and we had those fractions? Okay, so if the denominator is x minus h, and you were to set that equal to 0, what would x end up being equal to? The h, because you'd have to add h to both sides, right? So x could be any number except for the h value. The way that we would write that in set builder notation is fancy bracket, all real numbers x, such that x cannot be equal to h. Your h value is also going to be the vertical asymptote, so you can always say, oh yeah, this is the This is the vertical asymptote, which I'll start abbreviating this to VA, and the horizontal will be HA. So the horizontal asymptote is at y equals k. And very similar to this one, when you're doing the range, it's going to be all values of y such that y cannot be equal to the value of k. And yep, you can just use the horizontal asymptote for that. Okay, so for the parent function, we already drew in our asymptote. So it says, what are the asymptotes and the domain and range of the parent function? So y equals 1 over x. Okay, so we already labeled them. So we have vertical and horizontal. Vertical will always be x equals, because every vertical line starts with x equals. Okay, and then horizontal is going to be y equals, always. Now, do you guys remember with the asymptotes that I'm pretty picky on having the x equals and y equals? Do you guys remember why I'm picky about that? No, it's not because I have a type A personality. Do you guys remember why? Because if you're solving for x, right? If you were solving for x and x was equal to 3, and you just put 3 down, that's fine. That's cool. Why wouldn't it be cool if you just put 0 down here? What is an asymptote? It's a what? It's a line. Okay, so all asymptotes are equations of lines. So you have to have that equation with it. So because it's a line, you have to have the x equals or y equals. Okay, if you were to just put 0, that's a different type of value. Okay, so make sure you have your lines. Okay, now based on that, could you guys do the domain and the range? Just remember, your domain always starts with the x value, your range always starts with the y. So if you need some help, remember the domain is all the values of x except for it can't be the vertical asymptote. So if this is the vertical asymptote, then the domain just can't be 0. Okay, so the domain is related to the VA. Okay, the y cannot be 0 because that is the HA. And if you need to laugh like an evil villain, you can just say, wah-ha-ha, wah-ha. I got dad jokes all day. All right, so for example 1, you're going to use this graph as a guide. And because it says to do that, I made a table for this and then did the transformation. So describe the transformation, and then you're going to graph the function, and this is your new function, your g of x here. There are many different ways that you can graph this, so we'll talk about those strategies as well. Okay, so the first thing you want to do is describe the transformation. So if we start with 1 over x, we have 1 over x plus 2. The only thing that's different is what? Yeah, that plus 2, which is the horizontal translation. Remember that we talked about you have x minus. So if you think of this as x minus negative 2, that's going to tell you what your h value is. Sorry, that looks really small. Okay, So if you have 1 over x minus negative 2, it's really easy to see that your h value is what? What's your value of h? Negative 2. Okay, and if h is negative, you're going to the left. So this is a horizontal translation. 2 units left. Okay, so that is describing the transformation. Now it says to use this as a guide. Okay, so what I did is I plotted points for 1 over x, and then I did the translation for them. Okay, so we already listed some points for f of x. So if we start with f of x equals 1 over x, and we do our tables, and I like to do 2 tables. Do you guys remember why? Yep, you have your negative branch and then the positive branch. Sometimes they get shifted, but your x values that you're plugging in for the parent function will always be negative and positive. Okay, so let's just start with some of the ones that we did before. So we started with 1. So from above, our points were 1, 1, they were 2, 1/2, and they were 1/2, 2. I'm going to extend this a little bit further because on this graph here, see how it goes out to 5 and negative 5? Okay, so you could do the 5s or you could do the 4s. It really doesn't matter. But if you plug in 4, what's your y value going to be? Yes. So then if you did 1/4, then your y value would be 4. And that's just going to give you a better picture, okay? And if you want, you can always use those values. That's fine. You can always do that. Okay, so this is your f of x equals 1 over x here. Now, I'm gonna graph each branch separately, okay? So g of x equals 1 over x plus 2. So because it is 2 units left, does the 2 units left affect the x's or the y's? The x's. So all I have to do is the x value minus 2. Okay? So you can think of this 2 ways, okay? You could, first way, you could go to 1, 1, which is for f of x, and then you could do the translation. You could go 1, 2, there you go. Okay, so this is f of x. This is the what function? What do we call this function? Mommy, daddy? Parent. Okay, so this is the parent function. Okay, so if you have the parent function, you're just going to move this over. Okay, and then if you would rather, if you're like I like seeing the numbers and graphing them, so I would like to just subtract 2. So 1 minus 2 is negative 1, and then the y stays the same. Okay, so then we could keep doing that. So 2 minus 0 is, or sorry, 2 minus 2 is 0. You could also go to 2 1/2, and then you could go over. So it's up to you. Rashawn, you like my jokes back there? I think Rashawn rolled his eyes so hard that they went to the back of his head. Who has the best, cheesiest jokes out of your teachers?
Mr. Delaney.
Mr. Delaney has good ones?
He has the joke of the day.
He does?
Yeah.
I have to stop in there. Mr. Thomas, he has some really good dad jokes. Okay, one of them was, do trees go to the bathroom? Did I tell you guys this one? Do trees go to the bathroom? Yes or no?
Yeah. No.
Where do you think number 2 pencils come from?
Oh.
I can't take credit for that one. He said it in one of my classes. I was like, that is some high quality H2O.
That's a good one.
What?
Okay. So what's on the inside of a fire hydrant?
What?
H2O. What's on the outside of the fire hydrant? K9P.
Oh. K9. I get it. That is a good one. In the same family, too. And then notice that your Y's stay the same, okay? So you're doing 2 units left. I should challenge you each to find a dad joke, and every day we can tell one.
We have a joke every day at swim practice.
You do?
Yeah. It's our joke every Monday.
Every Monday. What was this week's? Do you remember?
It's pretty bad.
It's pretty bad. Now remember that you are going to be following asymptotes here, and so when we graph it, this is one of the branches. And then see how you have x plus 2 at the bottom, and we found the h value? Okay, so what is the vertical asymptote if our h value is negative 2? So remember, the vertical asymptote is at x equals h, right? So the vertical asymptote for this is x equals negative 2. Let's go ahead and put that in, because I think that's going to make graphing it easier for you. So x equals negative 2. And then the horizontal asymptote is, what is the k value? Is there any k value for this? Nope. So this one is x equals h, which is how we got it. For the horizontal asymptote, it's going to be y equals k, so it's y equals 0. So when you are graphing this branch, keep in mind that it's going to follow this line and it's going to follow this line. So all the values are getting closer and closer here and closer here. Okay, so that's one branch. Now we just have to do the other one. We just have to do the negative one. So again, if we start with the f of x, okay, with f of x, let's just do all of these but the negative version. Negative 1, negative 1. Negative 2, negative 1/2. Negative 1/2, negative 2. Negative 4, negative 1/4. Because this is for the parent function, f of x. This is f of x. This one's g of x. So when we do g of x, it's the same process. So g of x, you always just do f of x minus 2 for the x's. So what's negative 1 minus 2? Negative 3. So it's negative 3, 1. That will be our first point. And then we just, again, subtract 2. The y's stay the same. The only thing that's being affected is your g's. So negative 1/2 minus 2 is negative 2.5, or 2.5. This minus 2 will be negative 6. And negative 1/4 minus 2 is negative 2.25, or negative 2.25. And that's going to create our other branch. So negative 3, negative 1, negative 4, negative 1/2, negative 2.5, negative 2. This one is right there. connect those with a curve. So again, you do not want that to cross the lines. So this is going to follow here, this is going to follow here. Okay? Alright, for the next example, we're going to take a break from the graphing. We're just going to focus on identifying asymptote's domain and the range of a function, which are all very closely related. Okay, so for the asymptotes, remember it's x equals h, y equals k. Okay, so let's identify those values. The h is always the opposite of what you see here. So if it's x plus 3, the h value is negative 3, but the k value is always what you see. So you have the negative 2, k is negative 2. If you want to write it out like I did up here, like the minus, you could do that, but I think you guys are going to very quickly see that pattern since that's something that we've done before. Alright, so it says identify the asymptotes, and then the domain and range. So let's find all three of those. Okay, so for the vertical, we're going to have x equals negative 3. For the horizontal, we'll have y equals negative 2. And then remember, the domain is related to the asymptote. So if it's x equals negative 3, we have all values of x such that x cannot be negative 3. Okay, you could also think of it as, oh, I can't have the denominator be 0. So you could also think of it as x plus 3 can't be 0. So x can't be negative 3. So either way you want to think of it is fine. The range is related to your vertical asymptote. So it can be all values except for negative 2. Alright, and then I'm going to have you guys do part B. So part B is g of x equals 1 over x minus 6. Okay, so I'll give you a minute to do that. You have to do the two asymptotes and the domain and range. All right, let's see how you did. What was your h value? H value for this was 6. Okay, so your h value is 6. What was your k value? 0. Good. So h is 6, k is 0. So then from there, you could just do x equals 6, y equals 0. Your domain is x such that x cannot be 6. Your range is y such that y cannot be 0. How do we do? You said that was suspiciously simple. That's just exactly what we're going to do when we start graphing these other types of parabolas. Okay, so in order to graph the parabolas, we have to know how to find zeros and we have to know how to find asymptotes. Now, we have found zeros before. Remember, zeros are just what? What's another name for the zero? Yeah, they're the x-intercepts. Good. And sometimes we would also call them roots, but x-intercepts are the main ones. So x-intercepts are roots. Okay? Now, notice that this starts with if f of x equals p of x over q of x. Okay? P of x and q of x are just polynomials, and the p of x means the numerator, so whatever polynomial is in the numerator, and q of x just means whatever polynomial is in the denominator. And the reason why we want to give those names is because they're going to be used in certain processes for how to find zeros and asymptotes. for example, to find the zeros, all you have to do is set the numerator equal to 0. So if you're setting the numerator equal to 0, in the book you'll see it'll say set p of x equal to 0. Okay, and solve for x. Okay, so by p of x, they just mean the numerator. So if you want to put a little abbreviation there to help you remember, you can. Okay, and then for the vertical asymptotes, to find the vertical asymptotes, we are going to set q of x equal to 0 and solve for x. Okay, and of course our q of x is the denominator. Sorry. Okay, now the horizontal asymptotes have special rules, okay? Notice that in all of these rules, it says the degree of p, the degree of q, the degree of p, the degree of q, the degree of p, the degree of q. Okay, so this is all about the degree. Do you guys remember what the degree is of a polynomial?
The highest exponent.
Yeah, good, the highest exponent. Very good. So what we're going to look at is the degree, this says the degree of p, the degree of q. Okay? And if the degree of p is greater than the degree of q, what that means is there is no horizontal asymptote. Leave yourself some room here because we're going to do something else here. Okay? Now, if the degree of p is less than the degree of q, that means the horizontal asymptote is y equals 0. So there could be no horizontal asymptote. You could have y equals 0. Or if they're equal, then you get to make your own based on the leading coefficients. So if the degrees are equal, what you do is you take the leading coefficient, I'm going to put leading co, of the numerator, and you put it over the LCO of the denominator. And I'll show you what that looks like. Okay? And then we're going to put a little quick chart over here to help you with that. So like I said, this is exactly what you'll see in your textbook. Okay? Basically, you're comparing the degrees. When it says P and Q, it means numerator and denominator. So if the degree of the numerator is greater than that of the denominator, no horizontal asymptote. If the degree of the numerator is less than the denominator, then y equals 0. And if they are equal, that's when you do the leading coefficient over the leading coefficient. Okay, so for the horizontal asymptotes, we are going to have to reference that table so we know which is which, okay? All right, you guys ready for example 3? All right, we're going to do some graphing, and you can dig into the abyss and find your graphing calculators if you have them. Okay, so I know it's been a while. Your old pal misses you, I'm sure. Well, you miss it, I'm sure. So we are going to be able to use our graphing calculators to graph these. Okay, so we are going to identify the zeros and the asymptotes of each function. Then we are going to graph the function. So looking at this first rational function we have. Do you guys have any guesses on what we're going to do first? Yeah, that's right. We're going to factor if we can. So you always want to factor if possible. This is going to make the other steps easier. Okay, so we can factor this. We can't factor the denominator, that's just x. But if it's x squared, we start with x and x. What multiplies to negative 4 but adds to negative 3? Yeah, negative 4 and positive 1. Negative 4 plus 1. Okay, and then, just got some pencil shavings in there. And then what we're going to do from here is we are going to find the zeros. Okay, so your zeros, to find the zeros, this is where you set the numerator equal to 0 and solve. Okay, so if you're going to set the numerator equal to 0, let's just set the factored form equal. Because if you set the factored form equal, doesn't that make it pretty simple? This times this equals 0. So what do we know about these? Either x minus 4 equals 0 or x plus 1 equals 0, right? Okay, so x equals 4, x equals negative 1. We found the zeros. Now the zeros are the x-intercepts. So what we're going to do is we're going to write them as the x-intercepts as points because we're going to graph them, right? So if we're going to graph them, I already have 2 points for my graph now, which is great. So we're just writing our zeros as the x-intercepts. Okay, and after you find the zeros, now you can find the vertical asymptote. So to find the vertical asymptote, you can set the denominator equal to 0 and solve. Well, in this case, the denominator is just x. So when we set that equal to 0, it's just x equals 0. Just remember, you got to have the x equals anytime you write the asymptote because it is a line. For the horizontal asymptotes, though, you have to look at the rules above. Okay, which is compare the degrees. Okay, so let's look at the numerator. What's the degree of the numerator? So what's the highest exponent in the numerator? Am I going too fast? What's the degree of the numerator? 2. Yep, highest exponent is 2. Am I going too fast? Okay. And then what's the degree of the denominator?
1.
1. So 2 is obviously bigger. So we have the numerator is greater than the denominator. So let's go to our chart. Okay, so the degree is 2, this one is 1. So if the numerator is greater than the denominator, that's the first situation. So that means there's no horizontal asymptote, so you can just say none. And now we are ready to graph. Okay, so like I said, there are different types of rational functions. The rational functions that we looked at had a constant on top and an x on the bottom, but now we have a quadratic on top and a linear function on the bottom, so our graph is going to look a little different. So I would start by graphing the asymptote, and it's x equals 0, so that's going to be a vertical line right here, and we're going to label it. And remember, you can use a highlighter or a pen so that that stands out. And then we are going to plot the points that we already have. So the zeros were 4, 0, and negative 1, 0. So let's plot those. 1, 0. 1, 2, 3, 4. So when you're graphing this for your homework, you have to have specific points on it, okay? So I'll show you what I don't want you to do after we graph this one. And I will show you what I do want you to do as well. Okay, so let's go to y equals. Hello, old friend. Ready? Okay, when you do this, you have to put the top in parentheses because there's more than one term. So it's x squared minus 3x minus 4, and then divided by. Now, because this is just one term, you don't have to worry about the parentheses. Okay, and then we are going to graph it. Oh. And then, depending on your calculator, some of the older models actually put the asymptotes in there. Do the newer models, do you guys see the asymptotes or no? Okay, so you just have the line in there. What I don't want on your homework is something that looks like this. Because that shows me nothing except you know how to draw a sketch from what your graphing calculator is doing. Okay, what I do want you to do is use specific points. See, this isn't even labeled. I don't even know what your numbers are there, okay? So what we're going to do is we're going to use the table to help us. At 0, there's an error. Good, because what do we have at 0? We have an asymptote, right? It's undefined there, so yeah, it should be an error. Okay, at negative 1, 0, we have that. At negative 2, it's at negative 3, so let's graph that. At negative 3, I'm at negative 4.6 something. That's good. And then sometimes we actually want to know what's happening in between the whole numbers. So I'm going to show you how to use your table set to do that, okay? So go to second, table set. And if I want to know what's happening in between negative 1 and 0, I can just put in negative half. So let's see what happens there. Okay, at negative half, I'm where? What does it say? 1, 2, 3, 4. Doesn't it say 4.5? Okay, so see how that point is going to help me as I make this curve? Because now I have a direction of where I'm going here. Okay, so that's one part of the line. You have to make sure you graph all parts of it. Okay, now don't freak out that it looks like this. We can put it back together, right? So we just go second, table set, just start at 0 again. And then go back. So now at 1, I'm at negative 6, which is kind of off my chart here. And then at 2, I'm at negative 3. That's helpful. At 4, I'm at 0. Got that. At 5, I'm at 1.2. All right. Great. And really, that's all you need for these. So you can just curve this here. And you are connecting them with a curve. Okay, this is similar to a baseball seam. And that's what you got. Okay, so you just have specific points on there. Okay, when you do this on a test or a quiz, I will have you write down your tables just from whatever points you plotted. Okay, but as long as you have the points there and you have it on your graph paper, you should be fine. All right, so for B, we have f of x equals x minus 2 over x squared minus 1. So again, your first step is to factor where you can. So we should recognize right away on the bottom it's the difference of 2 squares. So you have x plus 1, x minus 1. From there, just go right to finding your zeros. So remember, zeros, you set the numerator equal and solve. So if you set x minus 2 equal to 0 and solve, you'll get x equals 2. So then this is going to be your point that you're going to graph. Okay, so see, that was pretty quick. So now we're going to do the vertical asymptote. So that's where you take the denominator, and again, just take the factored form. Once you have the factored form, then you know, you set this equal to 0, x is going to be -1, set this equal to 0, x is 1. Now when you have your vertical asymptotes, you have to make sure that you're using the x equals to indicate that it is a line. And then of course for the horizontal asymptotes, we want to compare the degrees, okay? So the degree of the numerator, what's the degree? Yes. Okay, so it's x to the first, so the degree is 1. What about on the bottom? 2. Okay, so in this case, it's 1 is less than 2, or the numerator is less than the denominator. So I'm going to go to my chart up here, n is less than d. Okay, and then from there, we know that y is going to be 0. Okay, and then we are going to come back and graph that. I just want to do this, the first step for C as well, because this one's a little bit different. And then after I show you how to graph that, you can graph this one. Okay, now for C, again, the first thing you do is factor. What you can factor here is the GCF of 4. You can factor out a 4 on the top. And then, again, your steps are the same. So when you find your zeros, you set the numerator equal to 0. Now when you do that, right, 4 equals 0, x minus 3 equals 0, can you solve this for x if it's just 4 equals 0? No. So that's not going to give you an x-intercept, but this one will. So 3, 0 is your x-intercept. And then the vertical asymptote, you just take your denominator, set it equal to 0, x equals 1. All right, what do we know about the degrees for the numerator and denominator here? They're both what? Yes. So degrees are equal. Okay? So in that case, you take the leading coefficient. What's the leading coefficient of the top? Yep, so what's in front of x? 4. So this would be 4 over 1. So in front of x is 4. In front of this x is 1. What's 4 divided by 1? 4. So then y equals 4. That is going to be your horizontal asymptote here. Okay, so you have to do the leading coefficient of the top and the leading coefficient of the denominator. Okay, and really they should just be these first numbers here. Okay, so let's go back and graph this one. And again, I always start by graphing my what? Nope. You could do your zeros first, though. Yes, I like to do the asymptotes because they are telling you, girl, stay in your lane. No, but they are telling you where you need to go. I'm just trying to make the back table cry with how bad my jokes are. Are you close, Jack? No. Okay. Okay, and then y equals 0. Okay, so y equals 0. Look at this. 1, 2, 3 asymptotes. So guess what? We're going to have more than 2 branches for this one. When you go to graph this on your graphing calculator, put in what's given. Don't put in the factored form, because then you'd have to add another set of parentheses. And we just don't want to get that crazy. Well, maybe you do. Just add the other parentheses if you're feeling like it, okay? Alright, and then we're going to graph. Alright, so see what we have here? We have this little parabola, and then we have two branches here. So again, we are just going to use, we're going to use our graph to help us. So our 0 was 2, 0, 1, 2, and this does cross the horizontal asymptote. That is fine. It's only the vertical asymptote that you can't cross. So when we go to our table, we're just going to pick out values from our table to plot. And again, you're just trying to get the best picture that you can. And if the whole numbers aren't giving you a good enough picture, what can you do? Yes, you can use the half numbers. Okay? Alright, I'll make sure that you guys have this correct in your notes, and then your homework will be online, okay? I'm going to actually finish this part in the video. Okay, so I have 0, 2 here. And then with this branch, I have 2, 0, 3, 1.25, and then these are really small because they're just above that line. So I am going to go to my halves. And at a half, it says I'm at 2, which means in between those I'm dipping down. And then at 1.5, I'm at negative 0.4, which is here. And so this is going to follow this asymptote there. And if I wanted, I could even go by quarters. I like that because it tells me, okay, you are dipping down here, and then this is just going to follow that way. Alright, and then we're going to finish that next one